Okay, so we have S orbital, which has only one shape, one orientation, which is this one. And we have p orbital has three orientations, 1, 2, and 3. That's why ml values, possible ml values, we have three: -1, 0, +1. Now we have d orbital. D orbital has L, which is equal to 2. When L is equal to 2, we have five possible values, which are -1, -2, -1, 0, 1, 2. So we have five. So we have five orientations also. We have -2, -1, 0, +1, and then we have +2. For when we have L, which is equal to 3, L is equal to 3, how many possible values for ML? We have, okay, so isulat sana itong mga possible values. We have -3,
7, ma'am.
-2, 0, positive, ay napay 1.
1 pa, ma'am.
Okay, -1, 0, +1, +2, +3. How many values?
7, ma'am.
Okay, we have 7. Hence, for F, okay, for F orbital, we have 7 orbital orientations. We have -3, -2, -1, 0, +1, +2, and +3. That's 7. Okay. So when n is equal to 3, when n is equal to 3, what orbital is that?
P, ma'am.
Huh? We have
P.
P. We have P because when n is equal to 3, angular momentum or L will be equal to 2, and 2 corresponds to PDI, to d orbital. D orbital. N minus 1, 3 minus 1, 2. Ang imong L is 2. So 2 possible orientations, we have 5. Now if we have 5, that is D. Okay. So we also talk about last meeting about who is the smallest. Okay, the smallest is we have
Particle. Electron, ma'am.
particles. Okay, particles. Electron is a particle. We have other particles pa jud. Okay. Then, is proton an elementary particle?
No, ma'am.
Okay, no. It is made up of what elementary particles? We have
Made up quartz and 1 down quartz, ma'am.
okay. All right. So also we have no kato ganina we have the smallest okay. So the smallest pa jud, in particles, elementary particles, we have neutrino. Neutrino is the smallest and lightest particle. Okay, not electron. We have neutrino. We have two Neutrino is ano pa siya, is classified into two. We have muon neutrino and we have also tau neutrino. Just like your electron, we have electron muon electron, and then we have muon electron, tau electron. Okay. So pa siya to. Last meeting. We also have electron configurations. Okay. Electron configurations. And we have also the valence or the outermost electrons. Okay, if we have what is the configuration of wait so, predictable. What is the configuration of manganese? Okay, we have this periodic table. Write the configuration of manganese. Tagat sabay off sa nako sa mukha. Okay, mag-off. Oh, magbayad ka. Ay, lain nga. Oh, lain. Bayad. Hmm. Hmm.
Ma'am, nakipanguta naman ba?
Oh, ato na. Oh. Okay, so, unsa to, Jelea?
Kanang na-observe na ko ma'am ba sa kanin bitang sa table of contents ma'am kanang ang ilahang sa element configuration bitaw ma'am kay dili arrange bitaw ma'am sa katong gihatag ni mga itong na ay 1 s sub 2 ma'am. Dili
What?
siya sunod pero parehas na ma'am pero dili siya
Like,
wala siya na
okay, so for example, if we have this vanadium, so ilahang gikuan ang configuration is we have AR. No, condense lang ha. AR 1, okay, 1, 2, 3, 4. 4s2. We have also 3D 1, 2, 3. 3D3. So, ang naadira is we have AR 3D3 4s2. Inana?
oh inana ma'am ba dali nauna ang S2 sa 3D.
Kani man jud ang ato ang pinakasunod no, mao jud ni ato ang ginasunod.
Mamang gisunod ma'am katong hatag nimo
Oh, okay. Oh, kani jud atong ginasunod. But also this one is also correct. Ang kuan lang giuna ra nila ang 3D3 kaysa sa 4S. Okay ra gihapon, pwede ra ni siya. Check gihapon ni siya. Pero kanina lang ato sundon gyud. Okay. Okay ra. Pero the two are correct. Okay. The two are correct. Sige. What about Mn? What is the electron configuration of manganese? Complete. Go. Wala. Okay.
sa ano man siya ma'am base sa periodic table.
Dire, oh.
1s sub 2 that
1s2, not sub. Kung sub, nasa
okay,
ubos. 1s2,
then 2s 2p6 3s2 3p6 3d5 3d5 then 4s2 ma'am.
okay. So, mo na yung gisunod, no? Unahaw to, katong ato, should. Unahon should nato ni. This one. Unahon na to that. Unahon na to that. 4S comes first with of comes first than 3D. Okay. 4S, we have this one. 4S, then we have 3D. Okay. Yan na ha. So we have next to 3P we have
3D5, ma'am.
unahon lagi nato ni. Kani atong sunon. Okay, 4S,
4S2,
3D.
and 3D5.
Okay. All right. Now, if you are going to look on the periodic table lang, then what if we will write the condensed configuration of your NB? NB. Condensed configuration of NB. We have condensed configuration of NB.
R of them sa
KR
4D45S1.
4, 1, 2, 3, 4, 5. Okay. 5S 2, 4D 1, 2, 3. 4D 3.
5S1 na, ma'am.
Ang 5S1 1.
Nga gali niyo nga kay milantaw may sa periodic mo ana pud ma'am.
Okay, we'll just follow this one, ha? Okay. We have RBSR. SR. In the case of platinum, sometimes mong good, in the case of platinum, is half filled is better than being full pud usahay. Okay, so buo ng 5S, then ang gibutang nila dito sa 3, may mabot din sila sa 4D4. So, ang inyong pagsulat, mahimo siyang 5S1, 4D, 4D4. Okay, 4D4, no? Okay, follow lang gihapon tani, no? Follow lang tani. Alright. Na-i-full lang sa nato tanan. 5S2 and 4D3. Okay. So here, what's the outermost electron? How many?
4D3, ma'am.
4D3 and
5S2.
5s2. Okay, because when we have transition metals, nakatalk na ba ta valence electrons?
Yes, ma'am.
Okay, when we have if we have main group are no easier to identify the valence electron, just the 1, 2, 3, 4, 5, 6, 7. Now, but when we go to transition metals is we will include the s orbital, and also the n minus 1 d orbital. So here in this case, if we have 5s, so we will include the electrons in the 4d. If we have in the outermost, if we have 6s, then 6s, so we will also add the 5d electrons, the electrons in 5d orbital. Okay, so you add the s and the d for transition metals. Okay, so let's go, ha. What about PDAG? How many valence electrons? How many valence electrons in Ag? Hello? Nawa na pod ko. Hala, nawalang internet. Hello? Hello, hello. Hello? Hello? Napa ko. Hello? Hello? Ay, tara. Hello? Ay, nawala ko. Nawalang internet mong good.
Naara ka, ma'am.
Okay. Akong share screen. Ana na. Okay, nana.
Magkita ra pud, ma'am.
Sige, good.
Balik na siya, ma'am.
Alright. Okay, so what's the valence electrons of Ag?
Five, one, and four, then 10, ma'am.
Valence electrons na. Number of outermost electrons. Okay, we have 2 for s. We have 2 for s orbital. Then for d orbital, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so how many valence electrons for Ag? Okay, let's write first the.
11, ma'am.
Okay, we have 11. So 2 here plus in the d orbital we have 9, so that is 11. So that's why the charge of your uh, ionic charge. Okay, so we have positive 1 only. Sara di ay. Silver age. Okay, so anyways, that's how you compute the valence electrons of transition metals. You include the s orbital and the d orbital. Okay? So no problem with it. Then we also so ano na, no? We also talk about shielding, penetration, and then we also have nuclear charge. So all of those those affects the atomic orbital. Then we also have the trends in atomic size as we go down the periodic table. What happens to atomic size? As we go down the periodic table, what happens to the size?
Mo increase, ma'am.
Okay, it will increase. What about the radius? Atomic radius.
Decrease, ma'am.
Mo increase. Radius. Unsa din na radius? Okay, half of a circle. Kung dako kay imuhang, kung dako ang imuhang circle, then dako po imuhang radius. Okay, so the same atomic size and atomic radius, they have the same trend. Now, what about, we also talk about ionization energy. Who has higher ionization energy? Those that are nonmetals or metals? We know the trend for ionization energy. We have that one as we go across, ionization energy increases. Ionization energy is the energy required to remove an electron. Okay. Who has higher ionization energy? Kinsa man ang asa man ta maglisod og remove sa electron? Diri or diari? Ang dako or ang gamay?
Dako, ma'am.
Ang gamay, because ang gamay has greater attraction to the nucleus. So, taas ang imuhang ionization energy, ang taas imong minimum energy here to remove an electron. Kay di ba gagmay na kay ni dire, so meaning nagkaduol na kay sila sa nucleus. They are not, they are mas penetrated sila to the nucleus. Okay, don't forget the trends na lang ha. We have that one. Okay, so this time let's go to the models of chemical bonding. So we have, what are the chemical types of chemical bonding you have known?
Ionic bonding and covalent bonding, ma'am.
Okay, we have ionic bonding. What is the difference of ionic and covalent bonding? We have Justin.
Ionic bonding, ma'am, is non-metal to non-metal bonding, while covalent is non-metal and metal bonding.
Mm.
Ma'am, nakoy pangatanong
Mm. Yeah,
sa
isoelectronic. Okay.
electronic, ma'am, ba kay anak at last discussion, ma'am, nga ang non-metal mo oy mo lose og
Molus.
electron.
Mm-mm.
Ang metal mo gain. Then nagtanaw ko ga BE sa kon, ma'am, ba answer kay atong gipansira nimo, ma'am. Baliktad diya, ma'am, kanang ang non-metal mo imo gain, ang metal mo imo lose.
Oh, non-metal man siya ang mugain. Mugain. Metals mag-lose. That's why, nag-ano day ko? Okay.
Ma'am, anong kagapon, ma'am, nga ang metal mo imo gain. Then
Non-metal.
ko
Non-metal jud ang mugain. Okay. This one. Diba? This, mao man ni ang imuhang mugain. Because we have how many valence electrons if we have oxygen? How many valence electrons? For oxygen, how many valence electrons?
6, ma'am.
Okay, we have 6. Pila gali ang desirable electrons for them to become stable or to become isoelectronic with the noble gas?
8.
8. We
8.
have, okay, we have here, which is neon. Now, oxygen, this is oxygen and this is your neon. Because oxygen, no, kinahanglan siya duha ka buok, either he will gain or either he will lose. But because di niya malose ng daghan kaayo, okay, he cannot lose 6 electrons. So yung buhaton, he will gain. Unlike to lithium, lithium has only pila yung valence electrons? Pila yung valence electrons sa lithium?
1, ma'am.
1. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 1 valence electron. So, maura ng electron nga naa sa iyahang outermost o outermost orbital. Pinakalayo, mao ni ang mao ni ang electron nga pinakalayo niya, mao ni ang maora ni pod ang electron nga pwede nato i-remove or pwede nato ma-lose, pwede nato mag-gain. Now, he has only 1. Then he needs 7. Di man siya maka-gain og 7. Maglisod siya gain og 7. So, iyang buhaton, i-lose na lang na niyang 1 to become 8. Okay, i-lose na lang siya yung buhaton, mo-lose na lang siya kay gamay raman kay kong electron, i-lose na lang nako ni. But oxygen, the non-metals has greater valence electrons. Now, ilahang option is not to lose but to gain. I cannot lose the 6 for just the 2. So, akong buhaton, I will gain. Ang nitrogen, I cannot lose 5 electrons just for 3. So, akong buhaton is I will gain. Now, ano jud da siya, always gid na they gain and then they lose. Because it's easier for them to lose because they have fewer electrons. Now, in the case of non-metals, it's hard for them to lose. So, ilang buhaton is to gain. So, inana siya Jelea, no? Always lose and we have also gain for non-metals. That's why we have here that's why the charge of your metals are positive. Though they lose, they okay, though they lose, they have still positive charge. Again, unsa gali ang explanation nga imbis nag-lose nahimo na nun silang positive. Unsa ga ito explanation? Unsa explanation nga nung galus na unta sila then na positive noon ilang charge.
Kay mas gamay na lang ang number of electrons man kay nag-lose man sila o
Okay, mas dominant na ang positive, no? Kaysa sa negative. Alright. Now, then we have also oxygen. In the case of oxygen, that's why non-metals became negative na pod. Because they gain more electrons. Mas dominant ang imuhang negative charge nga electrons. Okay, nagdugang man ka. So we have gain. So always should na ha, always na sila gain and then we have lose. Okay. To become isoelectronic, when we say isoelectronic, the same number of electrons to the noble gas. Okay. Isoelectronic, same electrons to the noble gas. Okay. So, maupod na siya because mag-lose ra siya, moatras lang siya dito, diri na lang siya moadto, mas dali siya sa helium to become isoelectronic. But kay he has only 1 electron. Kay kung mugain pa siya 7 electrons, taas pa kayang labangon, 7, 7, 7. Maabot lang niya ni. So, murabag ka ng, murag nangita siya redirection. Instead of coming to neon, Instead of becoming isoelectronic with neon, because taas pa kayo mong labangon, so I will just lose to become isoelectronic with He. Now, for oxygen, ang yung pinakaduol is kanin neon. So, di na siya kinahanglan nga mulus. Ang kaning oxygen, di siya kinahanglan mulus to become isoelectronic with He. Kaya I cannot lose the 6. Layo pa kaayo para mahimo lang kong He. I have Ne nga akong silingan. So, I will just gain 3. Mas duol ko dire. Okay. And for metals, previous noble gas. For metals, kalinya niya. But if you are going to write for electronic configuration, always previous. If we have I, previous noble gas. If you are going to write the condensed configuration, no, previous noble gas. But if you have barium, previous noble gas, xenon. If you have 80, still previous gas. Not di ka pa forward. Kaya pa forward ka, malapas na imuhang configuration. Okay? Follow pa?
Yes, ma'am.
Okay, so we have that one. Again, we have valence electrons. We have one valence electron here. One, two, three, 4, 5, 6, 7, and 8. Okay, valence electrodes. Now for transition metals, that is for main group. For transition metals, we have this one. You include the S, the S the electrons in S orbital, which is here, and then the D orbitals, electrons in the D orbitals. Because for this group, if we have 4 metals, we only have the S electrons in S orbitals. Then if for here, if for non-metals, we include the electrons in S and P orbitals, di ba? Okay, if we have nitrogen, what's the configuration of nitrogen? 1s2, 2s2, 2p. 2p, 1, 2, 3.
3,
2p3. Okay, 2p3. So what's the outermost electrons? How many outermost electrons? We have?
5.
Okay, we have 5 for S and 2 for S and 3 for P. So in the valence electrons for non-metals, we add the outermost electrons from S and P orbitals. Now, in the case of transition metals, we add S and D orbitals. Okay. Hello? And in the case of F block, this one, we have the S, then we have the D, because we still have, di ba, ang kani sila kay mo, sok-sok mo insert man sila dire. Mo insert sila sa period 6 and period 7. So we still have the D. Okay, D1. So we add that one S plus D plus D1 plus the F. That's the outermost electrons or the valence electrons for F block. But if we have platinum, the outermost electrons, okay, let's write the configuration, condensed configuration of platinum. We have Xe, xenon. Then we have after xenon we 4F14 na pa mo kag mo kita diri straight dit mo per me dili mong laktod 6s2
5D9 ma'am.
5d9 then
4F
4f
13 ma'am.
13 1 2 3 4 5 6 7 8 9 10 11 12 13 14 4f 14. What's the valence electrons or outermost electrons?
23 ma'am.
Apil day siya. 23. Apilon din yun eh. 4F14. Okay.
Yes ma'am.
We cannot
Ay, dili din ma'am.
delay because platinum is in the d orbital. So we only have 5d9 and then we have S2. Another explanation is we don't include F is that the first is platinum is not in the F block and also F is already filled. 14 it cannot F orbital is already filled. It cannot occupy new electrons. It cannot occupy another electrons because again valence electrons are the electrons that are appeal, okay, that are involved in chemical or in reactions. So they will accept or they will gain electrons, the valence electrons. However, F is already full, so it cannot participate na sa imuhang chemical bonding. So the valence electrons are only the from S and from D. You cannot include F. Because first, platinum is not in F orbital and also F is already filled. Full na siya, 14. Okay? So, magklase na ta. Alright. So, we have okay, what if this one, if we have EU, okay, EU, what's the condensed configuration of EU? EU. We have
Xe ma'am.
xenon gihapon. Okay, xenon. Sama ko, xenon. Then, after
6S2.
6s2, then magi pa siya diri, di ba? D1, 5D1, 5D1, then
D10 diri ma'am.
3F,
4F14 diri ma'am.
13 na rin ma'am sa periodic table.
pila?
4F14.
Ay, 4,
Ayan,
4, 4,
5.
4. 4F, EU man ta, EU.
14.
Maabot ba din 14 ang EU? 1, 2, 3, 4, 5, 6. for F6. Hello?
Xenon for F7, ma'am. Then 5D10, 6S2. Ano lagi?
Xenon
For F7, ma'am.
for
5D10, 6S2.
5D 10
5D0 dahil, ma'am. Dahil. 0 lang, ma'am.
for F7 5D0 5D0.
6S2 dahil.
Oh, 6S2 0 hindi 1. Wait sa predict table. 1. Di siya masulod man. Pilay atomic number sa lanthanum? Sa kaning unsa ni CE? CE
58, ma'am.
58. So dira siya mosulod.
58, ma'am.
Yes. Dira siya mosulod no. 5D1 anong dito 0. Anong 0? So wala na niya gi-feel ang Dino 3D. 3 ang 5 sa 5D. Sa to 5S2 D1 for F6. Okay. So atong problem is 0 no, iyang gikwad is for F7 siya dito, wala siya ga 0. Wala siya ga niagi sa D. Okay. We have this configuration for S2, 5D1, 4, F6. But still, if we are going to calculate the valence electrons will be valence electrons are pila ka buok? If you can still see, we have 2, 1, and then we have 6. How many valence electrodes? Hello? Hello?
Unsa mga element, ma'am?
EU.
3, ma'am.
Check 104. Check 104. 3? The 2. Add the 2, the 1, and the 6.
Apil ang F, ma'am.
Apil.
Diba, ma'am, D and S ra, ma'am, sa differentiation?
Diri. We are in F block.
9, ma'am.
Okay. 9. Alright.
Ang EU, ma'am, kay sa F siya block na anong bilong?
Yes. Here. F block. The S block, the P, the D, and the F. Okay. So 9. Now the same with what you have, no, same valence electron sa katong ganina nga imuhang sa inyong periodic table na Xe 4s2 and 6s2 and 4f7. So we have 2 plus 7, that is equal to 9. So ang problem lang nato ato is that wala na niya gi-include ang iyang D. Wa siya niagi sa D. Anyways, i-leave na lang nato na, no? I'll figure that unsa man. Unsay nasa yung predict table?
Ang EU, ma'am, kay 6S1, 5D10, o 4F14.
4F14, 6S1. EU man, EU.
Sa Eagle.
Sa gold man ata na yung gamin. Sabi na kay EU.
We have this one. Okay. Sige, unsa na address sa predict
Zero
table?
did I am
Okay. Alright, so ato kay niagita, no, then. However, same valence electron which is 9. 9. 7, yeah, 7 to 9. Okay. So figure out natin na what siya niagi sa D. Ano niagi butang D1. Okay, anyways, ano sa tanong biyaan sa nato na? Kimrag madugay siya ta. Okay. Okay. So you have that one, the electronegativity values. Okay. We have the types. So let's have lesson 4. Lesson 4, no, lesson 4. Lesson 4, lesson 3. Lesson 3. Okay, we have lesson 3, types of chemical bonding. We have ionic bonding, which involves the transfer of electrons and is usually observed when a metal bonds to a non-metal. So when we have metal and then we have non-metal. Okay, so for example, give me an example of ionic bonding. We have, okay, if we have Mg, magnesium and oxide. Okay, if we have magnesium oxide, Mg2 plus, because the charge is 2. Then we have oxygen, which is also 2 minus. So cross multiply, we have MgO. Okay, so the bond that is involved in MgO is ionic bonding because first it's metal and then we have non-metal. So if we have MgO, how many valence electrons of Mg do we have? We have how many valence electrons in Mg?
2, ma'am.
2. Okay, we have 2. So we have 1 electron And then here, let's put here 2 electrons. Okay, it's represented using dots. Okay, so we have two valence electrons. Now these electrons, mo ni sila atong gamiton for chemical bonding. Okay, we have Mg, and then we have oxygen. Now oxygen has how many valence electrons?
Six, ma'am.
So we write 1, 2, 3, 4. Okay, once you have filled every each sides, is mubalik ka 5 and 6. Okay, so we have that one. Now we have 6 valence electrons, and then we have Mg. Now because unpaired electrons are very reactive, so that's why they will be mao ni sila mga electrons to be involved in bonding. So we have Mg for this electron. This electron will transfer. Now, why is it na kanina electron, this electron will transfer to this electron to form a bond. Okay, so this electron will transfer to this side. So, forming, so mahimo na noon siyang duha na diri ka electrons. Okay, or we can form a bond there. Then we have also this electron will transfer to this side because the electrons from lower electronegativity. Okay, what's the trend of electronegativity? We have increasing. Okay, increasing electronegativity as we go across the table. So MgO has lower electronegativity than oxygen. That's why the electrons from MgO will transfer. So kwaon siya sa imuang oxygen. So forming a bond. We have Mg. Oh, so we have that one. That is ionic bonding. Now, if we have covalent bonding, say for example, if we have carbon, so how many valence electrons for your carbon? 4 valence
4, ma'am.
electrons. So we will write 4 electrons. Now, if we have this one, CH4. Okay, if we have CH4, so hydrogen, how many valence electron for hydrogen?
1, ma'am.
1. So we have 1 now. Because it's covalent bonding, so it only involves sharing. So the electron from your hydrogen will be shared to carbon, and this electron also will be shared to hydrogen. So forming C. Okay. Okay. Then we have, let's put another carbon because these electrons are still reactive. So we have, let's react that one with another hydrogen, or then these electrons, let's react that one with Cl. Cl has how many valence electrons?
7, ma'am.
Okay,
7,
7.
ma'am.
Okay, we have 7. 1, 2. I sorry. Okay, when you write 2, oh god. When we write the each sides 2, 3, 4, 5, 6. Okay, then ako 7. 7. So this electron from carbon will be shared to Cl, and electron from Cl will be shared to carbon, forming another bond. So we have unsa man? Okay. Dayon. Then, sa siya. O paghilam sa... Okay, we have... So forming Cl, and then we have here the H will be shared, and electron from carbon will be shared, and another Cl here. So electron will still be shared. So forming a bond, we have H here, and we have a Cl. Or we can put that into a line bond structure, which looks like this: Cl, H, and then we have Cl. Okay, so that is covalent bonding. So in, instead of transferring, so it is being shared. So like this one, this electron is transferred. Look at the arrow. So adto jud siya sa oxygen, and then we have here two oxygen. Unlike in this, look at the arrow, it is being shared. So we have covalent bonding. Then we also have metallic bonding. It involves electron pooling. So we have sea of electrons. We have electrons, electrons, electrons. Daghan kayo. Okay. Mura pagdagat of electrons. Daghan kayo. Alright. Electron pooling. That it's involved with metal bonds to another metal. Okay, we have Lewis dot symbol. Now, when we write Lewis dot symbol is we take note of the valence electrons, how many valence electrons. We can write this one. This is correct na ang imuhang bond pair is nasa babaw, or we can put it here or on this side or on this side. So, sila tanan is correct. Okay, just take note that when you write the Lewis that symbol is that first side, one electron, second side, one, third side, fourth side, and then balik na lang din ka. Not first side, i-feel na nimo na silang duha, and then ana, okay, it's not correct. Okay, just like your your electron distribution in the orbitals. Ano din siya, dapat tagsa-tagsa sa. Then we also have Lewis symbols and bonding for metal. Total number of dots in Lewis symbol is the number of electrons the atom loses to form cations. Is it true? Now, how many? If we have calcium, what is the valence electron of calcium?
2, ma'am.
2. How many atoms can calcium lose? Or how many electrons can calcium lose?
2 said mo.
Okay, because we have that one. For metals, the total number of dots is the number of electrons the atom loses. However, for non-metals, the number of unpaired dots equals the number of electrons the atom gains to form an anion. Okay, if we have nitrogen, how many valence electrons? 5. Okay, so yes, we have 5. Now, how many electrons does the nitrogen can gain in order to become isoelectronic with neon?
3, ma'am.
3. Now it says that here the number of electrons gained is equal to the number of dots. If we are going to count the dots, 1, 2, 3. So 3, 3. So that is equal. are the number shares to form a covalent. So which means that if we have three dots, then these three electrons will be shared to another atom or to same atom like N2. Okay. We have also octet rule states that when atoms bond, they lose, gain, or share electrons to attain field level of 8 electrons. Okay, in the case of magnesium oxide, who loses an electron?
Ito to, ma'am?
In the case of magnesium oxide, who loses an electron?
Magnesium.
Okay, magnesium. And then oxygen gain. So, muna, balhin siya. Transfer. Okay. But for covalent bonding, it is sharing. No. Bit na ta. So we have the valence electrons. We have lithium, beryllium. Okay, so for transitions and inner transition metals, we do not include because there are lots of exemptions for them. Just like here in sulfur, in phosphorus and sulfur, they naanapod ni sila exemptions in octet rule. So samot na ang imong mga transitions and inner transition metals. Okay, as you can see, here the number of dots are the number of electrons which are equal to the valence electrons. So unpaired electrons are very reactive, so mo na sila mo form new bonds to another atom. Okay, so just don't forget the trend. We have one valence electron, two, three, four, five, six, seven, and we have 8. Exemption is helium, which has only two valence electrons. Okay, we have ionic bonding. Ionic bond is formed when metal transfer electrons to the metal form ions which attract each other to give solid compound. Okay, we have solid compound. A total number of electrons lost by metals equals the total number of electrons gained. Okay, is it correct? Do you agree? Total number of electrons lost by metal is equal to the total number of electrons gained by nonmetals. If we have Mg, so the two electrons will be lost and the two also electrons will be gained by oxygen. Okay, so we have 3 ways to depict transfer of electron and the formation of lithium and fluoride. So we have lithium. Okay, we have lithium has how many electrons? Total number of electrons. Kanina lang. Electrons has how lithium? How many electrons?
3, ma'am.
3.
1.
3. On 3. But okay. So we have 3. Now, how many valence electrons?
1, ma'am.
Only 1. Okay, we also have fluorine. How many electrons?
9, ma'am.
9 ang fluorine. 9 ang fluorine. 6, 7, 8. Okay, we have 9. How many valence electrons?
7, ma'am.
7.
7.
Okay, so these 7 mao ni sila imha will be involved in chemical bonding. So we have lithium. Okay, one electron, one valence electron. Fluorine has seven valence electron. Now, because We have lithium, one electron, and then we have here also fluorine, which has one unpaired electron. So it will so lithium will lose the electron and the fluorine will gain the electron. So forming this one, forming lithium ion and fluorine ion. Now, if you wonder why is it that there's a charge, because this is ionic bonding. This is ionic bonding. The process of the steps in ionic bonding is that siya diretso, but first is we have the ionization of your lithium, and then we also have ionization of your fluorine also. So after that one, then lithium fluoride will form. Okay, we have that one. Now, in the case of sodium, sodium oxide, okay, if we have sodium oxide, we have an A plus and O2. Now, if we are going to write, okay, if I'll ask you to write the chemical formula of sodium and oxygen. So we have first sodium. Take note of the charge. What's the charge?
Positive, ma'am.
Positive.
1.
Sodium, positive 1. Positive 1. And then we have oxygen, which is charge. What's the charge?
Negative. Negative, ma'am.
Okay, negative 2.
2, ma'am.
Okay, negative 2. So we have negative 2. Now cross multiply. We have Na2 sodium 2 O Na2 oxygen. Okay. Now if we have that one, we put the oxygen in as in the central atom. So ato siya ipatunga because you put the higher, okay, the non-metals na lang. Okay, we have that one. We put the oxygen at the center. We have 1, 2, 3, 4, 5, 6. Then we have sodium. We have sodium has only one valence electron, so we have transfer. Okay, will be shares. No, it will be transferred. It will be transferred. Then we have another sodium here, so it will transfer also, forming sodium ion. Sodium ion, because we have two, so two sodium ion plus oxygen ion. So, in the third step, we have Na2O. So that is ionic bonding. So, if we are going to put that in an orbital, so we have the 3s out the valence electrons, and then we have the valence electrons in 2s and 2p. We have this one, 2s and 2p. So the electron from your 3s here will ibutang there first. So that with different spin, and this one also to this orbital. To this orbital. Opposite spin also. So forming this one and this one. So the formula is now N2O. We also have Afbao principle. Okay, now dito sa top, we'll always feel the lowest available energy before going up. Now we also have Hans rule. Hans rule is different spin. Okay, it should always have different spin. Okay, remember Hess's law? Mag-share ko ha, kadjut lang. O din, ako sa kong i-off.